Mars has been at the forefront of our imagination since the Italian Schiaparelli in the mid-1800s observed what he called canali. Canali is Italian for channel, a naturally occurring waterway, and it was misinterpreted in English as canals, manufactured structures implying an intelligent creator. Orson Welles, in 1938, stoked the fire with his broadcast of a Martian invasion on his radio broadcast of War of the Worlds. And now let's listen to a few seconds of that Orson Welles broadcast.
The metal casing is definitely extraterrestrial. Not found on this Earth. Friction with the Earth's atmosphere usually tears holes in a meteorite. This thing is smooth, and you can see its cylindrical
Just a minute.
shape.
Something's happening. Ladies and gentlemen, this is terrific. This end of this thing is beginning to flake off. The top is beginning to rotate like a screw, and this thing must be hollow.
He's moving! Look at that! Keep back there! Keep back there! Keep those men back! Keep back there! Keep those idiots back! He's off! The top blew! Look out there! Stand back!
Ladies and gentlemen, this is the most terrifying thing I've ever witnessed. Wait a minute.
Mars is not even our closest neighbor. It has also proven to be a difficult target to reach. Is Mars worth the trouble? Is there reason to believe that it may be home to hostile invaders? Or, at the very least, life in some form now or in its past? Stay tuned. Mars is one of the 5 planets known since ancient times, making it one of the brightest objects in our sky. Like the other planets, it lies along the Sun's equatorial plane, known as the ecliptic. Mars is unique in that it has surface features easily observed from Earth. Its changing appearance has led to much speculation as to the presence of intelligent Martians cultivating their vegetation and drawing water via canals from the polar ice caps down to the equator. Mars retrograde, or backwards motion in our sky, is also one of the inspirations for early astronomers' attempts to simplify our solar system. In order to fit observations of Mars' orbit, the geocentric, or Earth-centered model of our solar system had become overly complicated with epicycles. A heliocentric, or sun-centered model greatly simplified our views of our solar system and led ultimately to Kepler's and Newton's laws. Although the planets are generally considered to be in circular orbits, Mars has one of the more elliptical ones, with an eccentricity of 0.09. This makes perihelion distance noticeably closer than aphelion distance. As a result, Mars' proximity to Earth varies significantly over the course of an orbit. Here we see the alignment called opposition, where Earth and Mars are aligned to the same side of the Sun. In other words, Mars is opposite the Sun as viewed from the Earth. Not only does the distance of each opposition change from one to the next, but the size of Mars as it appears in our sky also varies. We see how significantly Mars changes in appearance from one opposition to the next. Mars is attractive as a place to colonize, not only for its proximity, but also because it shares some properties with Earth. First, the obliquities of the planet are very similar. Recall that Earth's obliquity, or its axial tilt, is 23.5 degrees. Mars has a very similar 25 degrees. That means that Mars experiences seasons in a similar manner to Earth. Because Mars is at an average distance of 1.5 AUs, its orbital period is 1.88 years. That means that each season on Mars is roughly twice the length of seasons on Earth. Earth's obliquity, due to the influence of the Moon, is considered to be fixed, and that it only varies a small amount. However, without a large stabilizing moon, Mars' obliquity is thought to have varied significantly over time. In fact, its poles may have once pointed directly at the Sun. This type of variation would be catastrophic to a planet's climate, from melting polar ice caps, freezing rainforests, all detrimental to life. Mars does have two very small moons, though, Phobos and Deimos, shown here compared to the Moon. Both are very close to Mars and share more in common with the asteroids than the moons of the solar system. Another similarity with Earth is Mars' rotation rate. A day on Earth is 24 hours. Mars' rotation rate is 24.6 hours. And yes, you can buy watches that work on Martian time. A significant disadvantage to colonization is the lack of a magnetic field. Only a weak, partial magnetic field has been discovered. This weak magnetic field not only makes navigation difficult, but it also means that the surface has little to no protection from cosmic radiation and charged particles emitted by the sun. It is not well understood why Mars no longer has a magnetic field. We see the protective aspects of Earth's magnetic field as aurora. On the positive side of Mars colonization, its mass is only 1/10 that of Earth. That means that the surface gravity is a very comfortable 40% that of Earth. That means a 200-pound astronaut would weigh only about 80 pounds on Mars. When comparing the radius of Mars to Earth, we find that Mars is just over half of the Earth's radius. That makes Mars' land mass about the same as Earth's dry land. Another challenging aspect to Mars is its atmospheric composition. It is significantly different than Earth. In fact, it more closely resembles the atmosphere of Venus. Additionally, it is very thin, only about 1% of the Earth's atmospheric pressure at sea level. This means no roaming the Martian surface without a protective spacesuit. The thin Martian atmosphere is the equivalent of 36 kilometers in height on Earth, or about 20 miles of altitude, higher than airplanes fly. An interesting and surprising similarity between Mars and Earth is in temperature. Parts of Mars has been measured as being a comfortable 86 degrees Fahrenheit. However, a bitterly cold 284 degrees below 0 Fahrenheit is also a reality. It is not uncommon for a 180-degree swing in temperatures at a single location. Although the atmosphere is very thin, it does produce large dust storms, even growing to planetary sizes. Here is one such occurrence of a dust storm that covered the entire planet. The dust can cover up any exposed surface, including solar panels for generating electricity. The dust is very fine, consistent with talcum powder, and can therefore be difficult to remove and get into really small spots. The Martian red surface is just dust, oxidized iron particles. In other words, rust. Below the dust is actually gray. More localized cyclonic storms have also been observed, such as this one seen by the Hubble Space Telescope. And dust devils are also very common. The Martian surface brings additional surprises. Mars is distinctly different between the two hemispheres, as if two different planets were cut in half and sewn together. Mars' northern hemisphere is very flat and comparatively smooth when compared against the heavily cratered highlands in the southern hemisphere. Like our Moon, the surface can be aged based upon the appearance of craters. The heavily cratered terrain in the south indicates a much older surface. One of the most prominent features on the surface is Valles Marineris. This 2,500-mile-long canyon spans 1/5 of the entire planet. This giant canyon dwarfs Earth's Grand Canyon, seen here to scale. The origin of Valles Marineris is unknown, but it is not due to plate tectonics. The edge of this entire region, referred to as the Tharsis Bulge, lies the largest volcanoes in the solar system. The largest of the volcanoes is called Olympus Mons. As seen in this scaled image, Olympus Mons dwarfs Earth's largest mountains. The presence of volcanoes helps answer a puzzling question about Mars. Why is its atmosphere so similar to Venus? Recall from the Earth video, the solar system planets have a solar nebula-first atmosphere, made mostly of hydrogen and helium. The second atmosphere was outgassed from volcanoes, and this included loss of carbon dioxide. The low pressure and cold temperatures resulted in atmospheric escape and the freezing of CO2 and water. There is no evidence of continued volcanic activity today. So where's the water gone? First, land features seem to indicate that water was once significant. Flows like this one and what looks like dry riverbeds are common along the surface. However, some hold that wind could have played a role instead of water. There's also evidence of underground flows exposed by impact, or other unknown events that cause water to liquefy from below the surface, and even evidence of water around the Phoenix lander. With such powerful evidence, we'll continue to look to Mars as a destination for humans. We have some compelling reasons to go. With such powerful evidence, we'll continue to look to Mars as a destination for humans. We have some compelling reasons to go. A similar day length and similar seasons, both important to making our human experience like that here on Earth. It is agreeable in G-forces. However, on the opposite side of the spectrum, we have no protection from space, from an atmosphere, or from planetary magnetic fields. We also have extreme temperatures and planet-wide dust storms. We'll have to learn to grow our own food. We'll have to take habitat modules or use lava tubes that are the result of past volcanic activity formed by flowing lava. This is the most likely option due to the prohibitive cost of sending heavy habitation modules. Until we get more answers, we'll just dream of benevolent Martian life, such as Marvin the Martian, or My Favorite Martian, brought to us by Hollywood.
James drove his RAV4 hybrid into no man's land and stumbled upon some stranded enthusiasts. He shared his sandwiches. He rescued their rover. He observed their methods. And was invited to join the crew for the remainder of the mission. No. James left to discover new frontiers and potable water. How far will you take the all-new RAV4 hybrid? Toyota, let's go places. James drove his RAV4 hybrid into no man's land and stumbled upon some stranded enthusiasts. He shared his sandwiches. He rescued their rover. He observed their methods. And was invited to join the crew for the remainder of the mission. No. James left to discover new frontiers and potable water. How far will you take the all-new RAV4 hybrid? Toyota, let's go places.